Hello! So today we are going to write our lab report, okay? So we've already collected our data for our volume lab, and now it's time to write our volume lab report. All right, so how do we do this? Well, first thing, you're going to have access to a very useful document, okay? And you'll have a document like this for every lab that we complete this year. And this document is titled Volume Lab Guiding Questions. Okay, so this document here tells you how to complete your lab. Okay, and then what's going on. So first order of business, let's go ahead and make a copy of this. All right, so you're going to need to make a copy of this guy, and I'm going to change this to Dr. J Volume Lab. Okay, I'm going to get rid of the guiding questions because I can't. So Dr. J, I won't actually grade this unless what is submitted doesn't have guiding questions. So the guiding questions are there to help you write the lab. It's your job to to answer those guiding questions or address them with complete sentences that are turned into a paragraph, and then to remove the guiding questions. And I'll demonstrate that here for the volume lab. Okay, and so every science report that's done professionally has 4 sections. Okay, all scientific publications have 4 sections. Introduction, which helps us understand the context for the experiment and the rationale or the reasoning behind the experiment. Okay, so what was being done, like kind of basically, and why was it done? And then why is it considered important, right? Why would anybody want to do this? Then the materials and methods section, which you will never need to write. Okay, so this right here is a completed materials and methods section. I don't believe in asking 8th graders to write materials and methods sections. So I'm always going to write that for you. And in fact, I've done so. Okay, so the materials and methods section is very short. It just references a document that you've already got. Okay, so it references not this document, it references this document over here. All right, so this document describes how to perform all of our experiments. Okay, and all we have to do is reference that document within our report. Okay, and that's good enough. So just leave this alone. You need not make any adjustments to it. Okay, results for this particular experiment or a series of experiments, we're just going to put our results table there. In the future, we'll have more to say in our results section, but we're just going to put our data table there. Okay, so we'll copy that in a little bit. And the deal here with the results is that the results section of a science report or a science publication contains what we've observed, okay? Usually in some sort of written format, often in a tabular or graphical format. So a lot of times you see graphs and tables and pictures of things, okay? That's what goes into the results. So the results just says what's been observed, okay? So the results section, if you'll sort of think back to your recent vocab lesson, the results section contains descriptions or measurements, right, of what's happened. No explanations or interpretations, okay? So that's what goes in the results section. Now the discussion section contains lots of interpretations and explanations. It can contain a few questions. It can contain commentary on the significance of the results. It can contain, let's see, it can contain, like this one here is, what has it taught you? So reflections, of course, then you can ask some questions, etc. So we'll go over all of these sections in detail as I show you how to write this report. Okay, so now we've discussed how a science report or a science communication or a scientific study or report is, or generally like a publication is structured. And so we're going to go ahead and go through this report, okay, with my data from the Marble Lab, okay? And what I want you to do is I want you to come up with your own answers for each question, unless I say otherwise. If I tell you you can basically use something that I've written, then you can do that, okay? Okay, so here we go. So first order of business, why is measurement in general / in the real world important? Okay, so let's see. I'm gonna go ahead and think about this and provide a response, and then we'll go from there. Okay, so I'll start by saying measurements are critically important for our daily lives, even though we don't often think about measurements. For instance, our clothes and shoes have specific measurements that allow us to determine whether those clothes and shoes will fit us. Okay, so that's one important thing. All right. Additionally, when we travel, our vehicles are able to measure their speeds while in or during transit. Okay, keeping all of us safe as we travel. Okay, so you'd be in real trouble if you didn't know how fast you were going down the road. All right, I mean, you could kind of, you could get a good sense by say if you're going by car or by bus by looking at the other cars and buses, but you really want to know exactly how fast you're going. And so every single bus, car, truck has a speedometer, all right, that allows you to know how fast you're driving as you're driving. Okay. So next question is, and I can start to get rid of this list interface, this list structure, right? So I don't really need lists there. This is the introduction. This should be bold actually. I'll go back and change that on the original document. So next question, right? So why do scientists perform measurements? So scientists measure during many or most experiments or observational studies, so that scientists can determine as accurately as possible what they're observing. Okay, so it's one thing if you're observing how fast. Let's say you're an engineer and you want to determine how fast a race car is going, right? So your job is to determine, say, whether a new engine is making this race car faster or slower than it was with an older engine, right? A previous engine. And so you better have a speedometer on that race car, and you better have additional methods of measuring that race car's speed so that you'll be able to understand whether the new engine is helping or harming the race car's performance. Okay. And in our case, right, we were measuring, well, so we'll get to that in the next question. Okay, so let's go ahead and just attach this to the previous sentence. So as we travel, period, space. Okay, so now you see how I'm answering these questions and then I'm stitching the answers together into a paragraph. Okay, that's what you're going to do. So that's how you'll turn these in. So in this lab, what are we measuring and what are we hoping to learn? Okay, so in this lab, we measured, or in this case, it's just me. I measured the volume, mass, circumference, and diameter of a marble in order to determine the marble's volume and density. Okay, boom, right? So that's it, okay? And you can write a sentence that's very similar to the sentence that I just wrote, but of course you're gonna be writing not about a marble, but about a golf ball, okay? So you're writing about a golf ball, but your sentence can look very, very similar to that, all right? That we've done essentially the same thing. And this is a good way to concisely state what we've done. Okay, so materials and methods section, just leave this alone. I'm going to make this bold. You won't have to because I'll have fixed the font, but I'm going to make that bold. I'm going to make this bold. I'm going to make that bold. While I'm thinking of it, I'll just go ahead and do that in these other bold, 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 bold. Okay. So we're going to put the data table here. So my data are right here. So I've got to go ahead and copy all these guys. I use Control C. I copy. And then actually, I think I just want these. I don't think I want all of that. So I'm going to Control C, copy this thing, copy here, and then going to remove this thing because I don't need it. Control V, paste unlinked, I think is what I want to go with. And there it goes. Okay. And that's all for the results this time. And then discussion. All right. So in general, were most of our measurements accurate, and how do we know? So let me just answer these as I go along, and then I'll erase them. So I need to hit Control B again to get rid of the bold. There we go. Okay. So most of my measurements for the marble, or measurements of the marble, I think either one works, are accurate, as evidenced by the generally low percent errors for each measurement. Okay. And so that answers both of these questions, right? So they were accurate, and then that's how I know. The low percent error tells me why. Okay, which measurements were the most accurate? So the most accurate measurements were well, so let me say the accurate volume measurements were obtained. So which measurements were most accurate? Let me change that. Well, let's see that like that. So the most accurate volume measurements were obtained by directly measuring the marbles. And I mean, you can look here, right? So the paper and ruler, the C-clamp, and the calipers. Okay, so really all four of these: beaker, paper and ruler, C-clamp, and calipers. So by directly measuring the marbles volume with a beaker, and indirectly measuring the marbles volume through measuring its circumference, with a piece of paper and ruler, and measuring its, or the marble diameter with a C, things like that, clamp, and separately with calipers. Let me check this sentence to see if this sentence is decent. The most accurate volume measurements were obtained by directly measuring the marble's volume with a beaker, okay, and indirectly measuring the marble's volume through measuring its circumference with a piece of paper and ruler. And let's kind of break that up. Measuring the marble's diameter with a C-clamp and separately with calipers. Okay, that sentence is a little brutal. I'm going to measuring the marble's volume through measuring its, let's go with just this diameter piece, its diameter with calipers. With calipers, boom. Okay. Those were the two most accurate measurements. okay? Those are the two most accurate measurements because we had beaker there and we had calipers there. These other two were pretty accurate, but for the sake of just like not focusing on so many different measurements, like 4, which seems like too many to me, I'm just gonna focus on the two most accurate measurements, okay, in my discussion here to answer this question. So I'm just showing you that like even I can sometimes wind up, having to revise my writing, okay? And so let's just focus on those two. And then why do you think these measurements were accurate? Okay, so measurements were accurate. And then this time I'm inserting opinion, so I could say I believe. So I'll put that up front. So I believe these measurements were accurate because in the case of the beaker measurement, I accurately assessed the change in volume, okay, as the marble was added, okay. It looks like I typed something too many times. There we go. Okay, and then separately, so I believe that the diameter measurement taken with calipers was accurate because the calipers are a precise tool that facilitates accurate measurement. Okay, like the calipers are used for like the job of calipers is to get super accurate measurements, and they did not fail us in this case. Okay, there was barely any percent error in our volume result. Okay, thanks to the calipers. So the calipers were phenomenal. Okay, so this question's been answered, right? Which measurements, and this could say not measurements plural, but measurement or measurements were least accurate. So the least accurate measurement by far was that completed, or let me say that was completed and I'll go with accurate volume measurement. Measurement was completed by the displacement method. Okay, and so the issue here, so this measurement was difficult because ensuring that the brim of the beaker was full saturated before addition of the marble was difficult. Thus, I think that the brim of the beaker was fuller / more saturated after the addition of the marble than it was before the addition of the marble, hence, or sorry, as evidenced by the unusually low volume provided by this measurement. Okay, so unusually low volume, and I can say 34% error provided by this measurement. Okay, so now I'm almost done. I've got one last thing to learn here. What have these experiments taught you about measurement? And this is a personal question, right? So you can answer this in your own words, however you feel, right? So what have these experiments taught me about measurement? So These experiments taught me that the volume of a marble or any other measurable object or is objective value. Okay. Each, so I say each, but 4 of the 5 measurement methods produced accurate results with error percentages below 8%. Okay, so these results taught me that I can potentially obtain accurate volume measurements through any of several different methods. Okay, and so now I can go ahead and erase the rest of this, right? And I'm done. Okay, that's my lab report. That's it. Okay, that's a completed lab report. That would get 10 out of 10 for this assignment. All right, so now you understand how to write a lab report, and you have your data, and you have your thoughts, and you have one thing I didn't show you with regard to like the first question. Okay, so if you look at this first question, why is measurement in general in the real world important? I mean, if you're stuck, right, or if you don't have a good answer for that, just Google it. Why is measurement important? And then you'll find a bunch of interesting, articles, websites, or other commentaries on that question, right? And so that can help you get off to a start, okay? But you've got your thoughts, you've got your data, and you've got Google, okay, and all of your instructions, and you got this video, all right? Feel free to rewind and rewatch, okay? To get this done, so to get this assignment done. So good luck, all right? I know you're going to do wonderfully, but as always, may all of the forces be with you.